Algebras. Welcome to your Chapter 8 Lesson 2 notes, all about solving quadratic equations by factoring, where we are going to take what we learned about getting standard form of our quadratic equation and what we know about the zero product law, and we're going to put those two things together and solve quadratic equations by factoring. Now, in the first lesson, the second thing we learned was all about that zero product law that I just mentioned. That when you have pieces multiplying together and you know that their result is equal to zero, then you know that at least one of the pieces must have been zero. So what you do is you go back and you figure out, well, which of the pieces was zero or what would have made my pieces zero. And that's exactly what we're starting with here. If I've already got these three factored pieces, then what I do is I do what I like to call the T-chart step, where I set each of the factors equal to zero, and I've created little mini or linear equations to solve. So you set x equals 0 here, you set 2x minus 1 equals 0 here, and you set x plus 3 equal to 0 here. So you set each and every factor equal to 0 because this times this times this is 0. So we know that there could be a 0 in any of those three spots, and we want to know what are the values that will give me those zeros. So the first one is great because x equals 0. Well, there's one of my answers. There's nothing to solve. X is already by itself, and one of the values that would make this whole thing 0 is 0, right? So there you go. There's one of the answers. The other one over here, okay, we've got to get x alone. So we start by adding 1 to both sides of the equal sign. Cancels there. You get 2x equals positive 1. And of course, to get x all by itself, you divide both sides by 2. And you could make this a decimal if you so choose, but I leave these as fractions. So got x equals 1/2 as one of my potentials. If I plugged 1/2 as the x value in right here, and I multiplied and then subtracted, I'd get this to be a 0. And anything times 0 is 0. So that is one of my answers. So I've got 0, I've got 1/2. And then, of course, here, get x alone by subtracting 3 to both sides. And I get x equals -3. So my three answers, -3, 0, and 1/2, would all make that equation true if any of these were plugged in for x. So this is where we know the zero product law comes into effect, because if 2 or 3 or more things are multiplying together and you know their result is 0, well, what that means is that each of those things has to be tested out to see what would make it 0. That is how we take standard form of our quadratic equation, factor that trinomial, binomial, polynomial into all of its factorable pieces, and then set each factorable piece equal to 0, you've solved a quadratic equation. You've taken an x squared equation and you've made it easier to solve using the fact that 0 times anything is 0. So it's kind of cool how that all comes together, right? And so that's what we're going to do. Now, this is the first example I'm going to do with you. It does have the procedure right next to it, and this is the procedure I'm going to use every time I go through this. So now what I'm going to do is I'm going to get standard form of my quadratic equation, which will be ax squared plus bx plus c equals 0 form. So you got to have that one side equal to 0. I'm going to look at my polynomial and I'm going to see how I can factor it. Remember, there's lots of different types of factoring you could do. GCF, dots, trinomial factoring. You could have your number in front of x squared be greater than 0, so the 5-line method for trinomial factoring. Or even you might have multiple factoring completely. All of those could be in play here. And then I'll T-chart and I'll solve each individual factor set equal to 0. And then we'll check our answers. And I'll teach you very easily how to check using your graphing calculator. So make sure you have standard form. today's work will all already have standard form. So that's one less thing we'll have to worry about today. Tomorrow, we will have to make sure we have standard form before we begin. But how you check to make sure you have standard form, make sure that you are in descending exponential order with your variable, and make sure you have your equal sign and 0 on the other side. So equal 0 has to be on one or the other side of our equations. Then we look at our polynomial and we determine what type of factoring occurs. In this case, this is a trinomial that can factor to become two binomials. And let's see, they are, what are the factors of 2 that will add to give me 3? So x minus 2 and x minus 1. I factor that. Then I do my t-chart. So I set each factor equal to 0. And then I solve each factor for x. So I'm sure at this point we've done enough work where you can see, oh, well, let's see. I'd add 2 to both sides over here to get x alone. So x must equal 2 on this side. And over here, I would add 1 to both sides of the equal sign to get x alone. So x equals 1 on this side. Yes, you do still have to write each factor set equal to 0. That is the zero product law going into effect. So you have to make sure you set each factor equal to 0. Then you can go to the answer if you can see it without showing work. Then, of course, we put our answers in French curly braces because it's going to be more than likely that we get more than one answer now. And then we're going to check by substituting back into the original. So let me start with, so my original was x squared minus 3x plus 2 equals 0. So let me start with plugging 1 back in. So 1 squared minus 3 times 1 plus 2 should equal 0. And here's how I'll use my graphing calculator to check. So here's my graphing calculator, of course. Let me just pull it out a little bit to make sure. But I'm just going to plug that line of work right in. So this thing right here, it's what I'm going to plug in. So 1 squared minus 3 times 1 and then plus 2. So just plug that right in. There you go. 0 equals 0. There's one check. Okay, now let's take our other answer, which was 2, and we substitute that into the original equation everywhere we saw an x. So I'm going to give you a big hint here. Are you ready? We're just substituting a new number back in. So press second and the plus sign, and it goes back to your last entry. And now if you just arrow left, in here, you can just change that to a 2. Okay, so I'm going to arrow left again and change that to a 2. That's the value that I want in there now, and then press enter. And there you are. 0 equals 0. It checked. 4 minus 6 is negative 2. Negative 2 plus 2 is 0. That's how we do it. That's how we're doing all of these. So you just have to be able to know which type of factoring you're going to be using. And that really is the key. And that's why chapter 7 was just so important, because that's what we need moving forward, is to be able to know, how do I factor this polynomial? Okay, what kind of factoring will this polynomial bring me? Okay, so I zoomed out there, but actually I'd like to zoom into number 2. So let's do that. Okay. So again, like I said, today is everything will already be in standard form, but just double check it. X squared minus 7x plus 10 equals 0. Okay. What are the factors of 10 that are going to add to give me a negative 7 in the middle? That would be 5 and 2, right? And both negative, because the bigger factor always has the same sign as the middle. So 5 definitely had to be negative. But both of our binomials will have the same sign this time, because if the end term is positive, these are the same sign in your binomials, and it is the same sign as the middle, and we are adding to get the middle number. So just review of all our factoring pieces from chapter 7. So now, of course, that I have this in factored pieces, I do the t-chart step, which is set each factor equal to 0. And now solve to get x alone. In this case, because they're integers, it's a little bit quicker. So I get x equals 5 and x equals 2 as my answers. I put my answers in my French curly braces. As you know, I always do them in numeric order. So, you know, greatest or the lowest to highest. And then I need to check. And by checking, what I do is I substitute these values back into the original equation for x. And again, I showed you how to use your graphing calculator to do this. So we would just type in front parenthesis 5 and parentheses squared minus 7 times 5, and then plus 10 at the end. And we make sure that this zeroes out. And it does. So 0 equals 0, good to go. Next. Okay, so now we plug in 2 and double check to make sure 2 makes this true. Okay, and I taught you just now, if you do second and enter and just arrow left to change this to the other answer, which in this case is a 2. So I'm changing both of these to be a 2 that I am checking for x, and then I press enter. There it is. Works out both times. So nice easy check there. Make sure you know how to factor. That's going to be the key. Knowing how to factor here is going to be the key. So we're kind of putting all those pieces together. Speaking of, there's lots of different types of factoring. There was GCF, there was dots, there was trinomial into binomial, there was what if A is greater than 1, factoring completely. And you have to be able to identify what type of factoring you're doing, because now the directions won't say, oh, factor by GCF. So if I've got a binomial, my only options are GCF and dots. And for dots, you have to have a perfect square minus a perfect square. In this case, 2 is not a perfect square, x is not a perfect square. So I don't have that. So I have to have a GCF then. And what are both 2 and 4 evenly divisible by? 2. What are both x squared and x evenly divisible by? X. So 2x is my GCF. And then I make my empty set of parentheses to put my leftover binomial in. 2x squared divided by 2x is an x to the first, or just x left over. Negative 4x divided by 2x is a negative 2 left over. And now I've got my 2 factors. There's one factor times this factor equals 0. So it's still just take this factor and set it equal to 0, take this factor and set it equal to 0. And now you've still got these 2 linear equations to solve. Here, to get x alone, you divide both sides by 2. But of course, 0 divided by 2 is still 0. So x equals 0 is the answer on this side. Here, you just add 2 to both sides. You get x equals 2. That means my 2 answers here are 0 and 2. And I plug those back into the original equation to check. And I'll start with checking 0. And the beauty of checking 0 is anything times 0 is 0. So I get 0 equals 0. Didn't even need my graphing calculator to do that math, right? Anything times 0 is 0. That's the zero product law that we're using. So now I'll plug in my other answer, which was 2. So 2 times 2 squared minus 4 times 2 should be 0. 2 squared is 4. 4 times 2 is 8. 4 times 2 is 8. 8 minus 8 is 0. So there's another way. Notice I didn't even use my graphing calculator there because the math was so quick. I mean, I could have done that in my head for the other ones too, but I wanted to show you how you can use your graphing calculator to do your checks. All right. Do make sure you know what kind of factoring you're using. Make sure you're showing me your checks for the time being. If I see some good checks, I might start to waive that. Okay, but you want to be careful. You want to make sure you're doing that for the time being. All right. Now let's do a couple more. Oh, okay. X squared minus 16 equals 0. All right, well, x squared is a perfect square. 16 is a perfect square. We're subtracting, so you know how this goes. This is dots, difference of 2 perfect squares, and that always factors the same way. You make your 2 empty sets of binomials. You take the square root of your front factor, you put it in the fronts of your 2 binomials. You take the square root of your back factor, you put it in the backs of the 2 binomials, and you put different signs between them. Okay, the order of those binomials is not what's important. Having them correct is what's important. And of course, we set each factor equal to 0 in our t-chart. And then we solve. And what you'll find in dots is you'll get the same value, but the opposite signs of it. So when I represent that, I represent it as plus and minus 4. Okay? It is two separate answers, 4 and negative 4. And those are what I have to check. So 4 squared minus 16 equals 0. Well, of course, 4 squared is 16, and 16 minus itself is 0. And then, of course, negative 4 squared is also 16, and 16 minus 16 is 0. So you can see what we're taking advantage of here is the fact that a negative times a negative is still a positive value. And that's why we get two answers out of one of these. Makes sense. Okay, last one that we'll do together, of course, is number 5, where what should really set me off knowing that this is factoring completely is the fact that there's an x cubed. There's an x in every term of this polynomial. And that should start to trigger that there's going to be a couple factorings that happen. Okay? Notice all the numbers present are divisible by 3, 3 and 12 and 15. And you can pull an x out of every term. So a GCF here is going to be 3x. And then let's see what that leftover trinomial is. Okay? 3x cubed divided by 3x is an x squared. Negative 12x squared divided by 3x is a negative 4x for the middle. And negative 15x divided by 3x is a negative 5 for the end. So that is now a trinomial that can factor into two binomials. So this, of course, is the GCF that we bring down to the next step because it doesn't go anywhere. And it is going to give me an answer, so I must have it present. Okay, because there's a variable there especially. It's going to be giving me a value for x that I need. Then, of course, here, what are the factors of 5 that subtract to give me 4? Well, the only factors of 5 are 5 and 1. And what's bigger, a 5 or a 1? A 5. And so the bigger factor has to match the sign in the middle. That makes this negative. Since the n term is negative, these have to be different signs. That means this 1 must be positive. And now I've got 1, 2, 3 factors that could all give me answers for x. So I have to set all of them equal to 0 in my t-chart. And so, of course, that is what I'm doing right now. Set them all equal to 0 in my t-chart. So you've probably figured out that when you have just something times x equals 0, that your final answer for that is going to be that x equals 0, because 0 divided by any number is still going to be 0. Then over here, add the 5 to both sides. You get x equals 5 as a potential factor. Excuse me, a potential answer for x, my bad. And over here, subtract 1 from both sides. You get x equals negative 1. And so my 3 answers that all need to be checked, yes, are negative 1, 0, and 5. Again, I always list my answers for x in lowest to highest order in my French curly braces. You know, just listing the 3 things is fine by me, but I'm always going to do it that way to kind of keep some order. Now I'm going to check everything. So 3 times 0 cubed minus 12 times 0 squared minus 15 times 0 should end up equaling 0. So this is a great place to be using my graphing calculator for my checks because now I got a cube in my head. No, thank you. So 3 times 0 cubed. Oh, not that this is that challenging, right? 0 cubed is 0, 0 squared is 0, and times 0 is 0. So this one actually checks out pretty quickly, but let's get it in there just to get it in there, right? So that then we can continue plugging in different answers. So now we've got minus 12 times 0 squared, and then minus 15 times 0. So even though we know that this is going to easily zero out, yep, we still plug it in to check. Okay, now we've got to do that with the other 2 values as well. So now I'm going to do 5. So let me zoom out. I'm just going to go underneath the wording a little bit with my checks. Let me do the 5 over here, and then I'll do the negative 1 down here. So 3 times 5 cubed minus 12 times 5 squared minus 15 times 5. Wow, that feels like a lot. So let's press second and enter. And we're just going to arrow to the left and change this to a 5 because that's what we're inputting. Feels like a lot. Boy, how's that going to happen, right? Let's just check it. Wow, it works. Oh, okay. This guy zeroes out. Well, now we got to do that with -1 being thrown in there. And let's make sure that works. Boy, there's a lot of worry there with signs. So it's a good thing I've got this graphing calculator to help me. So second and enter gives me the last thing I typed in. So now if I arrow backwards, now because this is a -1, you have to press second and insert negative and then arrow to the 1. Okay, so because of there's going to be kind of 2 spaces that you need second and insert to get your negative. And then notice I arrow over so my cursor isn't changed anymore. And this is a 1 that I'm putting in. And then I do that one more time all the way over here. So second and insert. So that's the delete button, gets me the extra cursor going on. So negative, and then I arrow out and then come back to change it to the 1. Because otherwise I'd have to go back and delete the 5 anyway. And then, of course, plugging all that in, I get 0 again. It checks in all 3 of these, right? All 3 answers checked. And that's what I can use my graphing calculator to help me with. So use that graphing calculator to help you on these. So, of course, today, our equations are already going to be in standard form. Okay, I just want you to practice being able to identify the type of factoring and factor it, and then be able to set each factor equal to 0 in the T-chart and be able to get those different answers. Okay, so I really want you to make sure that's what you're practicing. Noticing difference of 2 squares, noticing GCF, noticing when you have to factor completely, right? So picking up on those patterns we were focusing in on in chapter 7 about the factoring, and now using that in this equation setting. Okay, so everything will already be in standard form. Okay, so I want you to follow those directions, follow that procedure each time. Okay, use these 5 examples to help you. They really are the basis for the whole homework. Let me know if you have any questions and need anything. Good luck, guys. Be seeing you soon. Bye.